As I said before, we can find here the difference between different results. In this case, it appears distance error the 5.6 centimeter. Now everything is calculated. Now it's rest to compensate, for example, the coordinates. Okay, pues we are going to use only to say that the coordinate that the application is going to use is the coordinate that is selected in this window, in this part. Okay, for example, in the station number 6, we are going to use the direct assignment, or the station number 5 is going to use the coordinate from the station 6. Okay, or maybe in the station number 7, okay, we are going to use the inverse intersection, no? Okay, this is one solution, the primary solution to use to compensate the traverses. Okay, we are going to compensate these traverses, okay, or this network before. Traverses, click on traverses, and now to compensate the traverses, we need to arrange the traverses, okay, to define the traverses. Well, we are going to select graphically each station that composite each traverses, okay. In this case, the different station, I'm going to click on different extension that composite the traverses, okay, and here is. I'm going to say to the software that it's a closed traverse, okay, it's very important. And for me, in my case, I like to save this configuration, okay. I'm going to export this configuration. I'm going to save in this file, the file .pol, save, okay. Because I like to save that because sometimes we need to repeat a lot of time the compensation to check the difference between different weights. Okay, so in this case, I'm going to compensate the traverses, and here is the window of compensation. Okay, overall, we need to check the different parameter. For example, the distance error at the end of the traverses, in this case is 6.6 centimeter, and the length of the traverses, or the error, the angular error that we can find, or the coordinate error that we can find in the traverses. Okay, it shows the primary coordinate for each station and the horizontal correction that you use to the compensation. Okay, we can select the weight of calculation, for example, the least square, or maybe proportional distance, or proportional increments, Crandall, etc. At even, we can fit in planimetric or altimetric, or both of them ways. So we are going to compensate by this way. This error we are going to compensate only to click on compensate. The software calculate by this way and show us the different residual that it's fine in the calcul. Okay, but the software advise us about its passing the test square chi, okay, statistical test, to allow us to know it's a good way to compensation. The compensation is successful. Okay, after this, we can print the resume of the calcul to include all the observation, all the coordinate compensate coordinate, and everything, to maybe to create a report or something like that. Okay, it's very useful to use that. Okay, it's everything. Okay, I'm going to accept. I'm going to click on OK. Okay, click on OK too. At the end, we can check we can find the final coordinate, the compensate coordinate for these traverses, and everything is calculated too. Okay, compensate. Okay, is a very useful and easy way. the same thing if we want to compensate a network. Okay, we can click on network. We can select, in this case, we can select graphically each station that we want to include, or maybe we can use a automatic way. For example, automatic, okay, and select all the station and all the observation that we can use to calculate, okay. And we can use compensate it the same like the last one, okay. Okay. Now we can check the final coordinate that we are use and the scale of the projection that we use, okay, for each station, okay. Okay, and now we are going to draw the final objective, no, to draw the points, okay. Pues we are going to draw the points. Here is going calculate. Now the application is calculating each coordinate for each point, observed point, and to show the list for each point by point. Okay, it lasts some minutes because there are some different calculus. Okay, we need to wait some minutes, and then we are going to draw automatically by code. We are going to represent it we are going to drawing all the entity, linear entity or punctual entity by block using the code database. Here is the finish point of drawing. Okay, we are going to draw all the point. Okay, and now we are going to say to the application how we are going to draw. We are going to draw using the codes. We can select the code database here, only to say where is the code database file. In the case, okay, and we are going to use this scale, okay, to define the text height in our drawing. Okay, we are going to click on OK and start to draw all the points along the street in the survey that we carry out in the field. Okay, and here it is. Okay, we can check the draw, all the entity, the linear entity, like a building, facade, like a big line, and everything. Okay, so only when it's ready, everything is calculated. All the calculates are saved in the file let file to if we need to check or to edit something, we load again. Okay, we are going to click on OK to pass to drawing steps.